The function f is defined f such that x maps onto 4 minus 2 times the absolute value of x plus 3, or the modulus of x plus 3. Sketch a graph of the function, state the range of the function, explain why f to the minus 1 does not exist, and solve the inequality f of x is greater than 3. Okay, so we're going to draw it. So a set of axes. Make sure you label your axes. You need to think that this can be written as minus times the absolute value of x plus 3 plus 4. Right, first of all, if you draw y is equal to the absolute value of x, the plus 3 means do a translation minus 3 zeros. So this point here will go along 3 units this way. Remember, it's plus, it's in the negative direction. And then we draw the graph. Obviously, it'll cut the axis here at 3 because this point will have moved 3. Right, then you can do the next two in either order. Right, I'm going to do the minus sign means reflect this in the x-axis. So we reflect it and get this. And then the 2 means a stretch parallel to the y-axis. So this point here will go here. This point here will go here. And so on. And you'll get a graph looking like this. It will go through here minus 6. This minus 3 will go to minus 6. And then finally, by adding 4, means that the whole of this purple graph here will be moved up 4 units. So translation 0, 4. So this point will go here. So that will become the point minus 3, 4. This point will go here. This point will go here. And so the whole thing just moves up 4 units. On the other side, this point goes up 4 units. This goes up 4, etc. This minus 6 goes to minus 2. And then we get a graph looking like that, labeling all the points of interest, minus 2, minus 5, minus 1, and then the coordinates of that point there. And we've got the graph of 4 minus 2 times the absolute value function of x plus 3. It's always better to think of this sort of graph like this. This is plus 4 and then it's minus. Okay, just drawing that graph out on its own. Okay, we had to come up with the range. So the range of the values of y that we get out. So these would be any value of y less than 4. And why does this function not have an inverse? Well, if you look at this point here, for example, minus 4 maps onto 2, and also minus 2 maps onto 2. So this is what's known as a many-to-one function. Therefore, there's no inverse unless you have restricted the domain. So we have to finally solve the inequality 4 minus 2 times the absolute value of x plus 3 greater than 3. So if we draw the line y is equal to 3, we need to find the coordinates of that point and that point. At this particular point, now you can think of this graph as 4 plus 2 times x plus 3 is equal, and then it's equal to, where it's equal to 3, because this is the graph of 2x plus 10. This is 2x plus 10. It's positive. So if we carry on solving this, we get 4, take the 2 in the brackets, 2x plus 6. So there you can see 2x plus 10. This is a graph of, this bit only is the graph of y is equal to 2x plus 10. And then 3 take away 10 will give me that 2x is minus 7. Therefore, x is equal to minus 7 over 2. And then for this bit, okay, we need to keep the minus sign in front of the inequality. All right, so this is the graph of minus 2x minus 2. You can see that minus 2x minus 2 is equal to 3. So keeping the minus sign is a good idea here. Here is plus. And then we're going to get 4 minus 6 minus 3, which is minus 5 is equal to 2x, and therefore x is equal to minus 5 over 2. Now we want to know where the actual function is bigger than 3, so that's going to be this little bit here. Okay, we don't include these points because because it's not including them here. So we're just going to write down that the solution is minus 7 over, x is greater than minus 7 over 2 and less than minus 5 over 2. And if you want to look at a graph done with GeoGebra, you get to see the same thing here. Okay, so this has been a video to show you how to sketch an inequality graph without using any technology and then using it to solve an inequality. I hope you've understood, and I thank you very much for watching.